Okay, we're going to start talking today about types of formulas. There's a lot of information I'm going to be giving you today so that we can work off of it. And some formulas you've seen already, like if I just write H2O, that is a formula that is called a molecular formula. And a molecular formula tells us the exact number of moles of atoms in the formula. So if you have H2O, you know that you have two H's and you have one O. That's a molecular formula. If I give you something like glucose, this is an actual better example of a molecular formula. I could give you C6H12O6. That would be a molecular formula. It's telling us I've got 6 carbons, I've got 12 hydrogens, and I've got 6 oxygens. And that makes up the entire formula. That's a molecular formula. Right. Now, the next type of formula, you good? Is called an empirical formula. And an empirical formula is the lowest whole number ratio of atoms in a formula. Okay. So let me give you an example of one, and then it'll be a little bit more clear what the heck I'm talking about here on the Monday morning after a break. Let's say you have CH4. Okay? The ratio of carbons to hydrogens is 1 mole of carbons to 4 moles of hydrogens. 1 to 4. I cannot reduce that any further. It is the lowest whole number ratio of atoms in the formula. There's 1 carbon for every 4 hydrogens. Okay? This is an empirical formula. It is also a molecular formula because it's telling me, molecular formula, that I have 1 carbon and 4 hydrogens. This is both empirical and molecular. I can't reduce it any further, so it's empirical, and it's telling me I have 1 carbon and 4 hydrogens, so it's molecular. C2H8 has 2 carbons and 8 hydrogens. That is a molecular formula only. It is not empirical because I can reduce 2 to 8 to 1 to 4. So this is molecular. Psst. They're always going to be molecular unless they're a salt. Okay? Molecules are covalently bonded substances. These are covalently bonded. That's why I'm using the word molecular formula. Okay? A molecular formula is a multiple of the empirical formula, where the empirical is the lowest whole number ratio. So this one right here is times 2. It's twice as big as this one. So what's the empirical formula of C2H8? CH4. If I went times 3, then it would be C3H12. What's the empirical formula of C3H12? CH4. So there's only one empirical formula, and then the molecular formulas are any multiple of that molecular formula. Do you understand? So what about if I gave you C6H12O6, glucose? Is that empirical, molecular, or both? It is molecular. What is its empirical formula? CH2O. Easy peasy lemon squeezy, right? This is molecular. This is its empirical formula. When you have the empirical and the molecular formula, am I going too fast or are you okay? So far, so good? You good? Okay, Nick's good. So we're all good then. All right, so we got CH4 again. Actually, you know what? I'll change it up. Let's do CH2. Okay, that's empirical. It's also molecular. It's the times 1, right? What's its gram formula mass? (14). 12 for the carbon. There's one of them. Plus 1 for each hydrogen. That's 2 more. 12 plus 2 is 14. So this is 14 grams per mole. What about C3H? Let's keep it simple. C2H4. What is it going to be? 28. Well, this is the empirical. This is times 1. This one is times 2. It's the next one up in the series. So, if this is 14 and this is multiplied by 2, then this has to be 28. What about if I did C5H10? What is its gram formula mass going to be? Calculator out. What is it going to be? 70 grams per mole. It is 5 times bigger. Okay. So far, so good? What about if I gave you something that had an empirical formula, C1H2O1, so like glucose, right? And I told you that its molar mass is equal to 90 grams per mole. Could you give me the molecular formula? Okay, think about what we just did here. So we knew that this one was the empirical, it's the lowest. And this is also going to be the empirical. What can I find of the empirical formula? Can I find how much this thing weighs? How much does it weigh? How much? 30 grams. 30 grams per mole. I want something that weighs 90 grams per mole.
You have to multiply by 3.
Right. So what's the molecular formula going to be? C3H6O3. You see how we did that? If I know what my formula needs to weigh, and I know what the empirical formula is, I can figure out what my molecular formula is going to be. Because it will always be a multiple of the empirical formula. So there's a couple of things they can do here. They can say to you, C5H20, and they can say, what's the empirical formula? C1H4, good. Or they can say, you have a compound with a gram formula mass or molar mass of 64 grams per mole. And they tell you the empirical formula. Can you give me the molecular formula for that? What do I have to do? Figure out how much this sucker weighs. So carbon is 12. And hydrogen, there's 4 of them at 1 apiece. So this whole thing weighs 16. There you go, C4H16. C4H16 would give me a gram formula mass of 64. Okay? So we talked about two types of formulas. We talked about empirical being the lowest and molecular being any multiple of that empirical, including the first one. Okay? Keep that in mind, because a lot of times I've seen them do that. They'll say, which of the following is both empirical and molecular? You're looking for the empirical one, right? Because the empirical one is the first one in the series, and the molecular is any multiple including that first one. Okay? All right. Keep all this stuff in mind. We'll come back to that in a little while. I am going to now do percent composition. So on the back of your reference tables, you're going to see a formula that says percent composition. It's the fourth one down. Okay, and the formula for percent composition is part over whole times 100. Nice and easy. Sometimes we want to figure out how much of a compound is one particular element or one particular part of the compound. I'm going to start with something nice and easy like water. And let's say I want to find out how much of this is hydrogen. What percent of this water molecule is hydrogen? So I'm going to use my formula, the part that is hydrogen over the whole times 100. We're going to take the part that is hydrogen. See, I wrote a P with a little H next to it. That means part that is hydrogen over whatever the whole thing weighs times 100. All right, water, we know the whole thing weighs what? 18. But I'm going to write it out for fun. So the whole thing weighs 18. So here is my whole thing. What's the part equal to? 2. I'm looking for the percent that's hydrogen, so my hydrogen weighs 2. It's the part that is hydrogen. So let's put them into our formula. 2 over the whole thing, which is 18, times 100. And you're going to end up with 11.1% hydrogen. And you all right with that? What do you got there? Is it delicioso? All right, let's find the part that is oxygen in water. So what does oxygen weigh in this compound? 16. Divided by the whole thing times 100. That's going to give us 88.9% oxygen. Notice that the whole thing adds up to what? 100, because the whole is 100%. All right, let's see if you can do one now. It's not hard. You can do this. You're smart. Okay, let's do sodium chloride. I want to find the percent that's sodium. That's a hydrogen, Kaufman. And the percent that's chlorine. Okay. So in order to find percent of something, we're going to take the part of that thing divided by the whole times 100. The percent is the part that is chlorine over the whole times 100. Do your gram formula mass over here, so that you have all the bits and pieces that you need. Sodium is going to be 23, right?
Yeah.
It was good. It was warm. I know. Then I came back here and I was freezing my bazunkas off. All right, Charlie. Give it a go. Tell me what this is over here. What's the total? 58 is the total grams per mole. Okay, you see how I wrote them over there? Nice and neat. So I know that my whole is going to be 58, and my part that is sodium is going to be 23, and the part that is chlorine is going to be 35. Now all I have to do is stick the numbers in. Part that's sodium is going to be... Okay, yes, that's right. So the percent is going to be 39.7% sodium. We could round that to 40% just to make our lives easier. Okay? But 39.7% or somewhere close to that. Now, you should be able to do, without doing any math on your calculators, tell me what chlorine's percent is going to be. If this is 40%, what is this one going to be? 60. Let's do the math and just double check ourselves. Okay, this is going to be 35 divided by 58 times 100, and that's going to give me the percent that's chlorine, and the percent that's chlorine is going to equal 60.3% chlorine, which is going to be 60%. And you're going to notice that these two suckers add to 100%, which they should. If you get 99.9 or 100.1, it's just a rounding thing.
So you would like round the percents to the
You can.
actual number?
You can. Okay, it's not that precise. We're not worrying about sig figs. We're just getting the percents. Okay? Any questions? Noah, you good? Nora, you good? You understand everything? So far, so good. Okay. We're going to level up. How much time do I have? 10 minutes, I can do this in 10 minutes. All right. CuSO4 dot 5 H2Os. Okay, let's talk about what this means. First off, what is that, CuSO4? What kind of copper sulfate? Copper 2 sulfate. Wait, stop. I don't want this whole thing. Take this. Hold on, Ryan. Don't go anywhere. Alright, so we know that this is copper 2 sulfate. That's not new news. That's just this part. Then we have this really cute little dot right here. And in math, that dot means multiply. However, we cannot be like math because we are not math, we are science. And in chemistry, that dot does not mean multiply. It means attached to. That's what it means. No. It does not mean multiply. I'm making a big stink about this because I don't want you to multiply. So everybody listen really carefully. Abby, you all right? You good? Okay. Just making sure you're still there. Okay. I'm going to draw it for us so that we can see what this actually means. Put your phone away. Okay, put your calculator away. You don't need it right now. All right, so you got copper 2 sulfate. Now I'm going to make that copper 2 sulfate in a little cloud because it's cuter that way. Okay? That's this right here. This means that attached to that copper 2 sulfate, there are 5 water molecules. 1, 2, 3, 4, 5. Yep, exactly. That's how I feel. So, this copper 2 sulfate, which is right here, has 5 water molecules attached to it. This is called a hydrated salt. It is hydrated because it has water on it. This is a hydrated salt. Here's my salt. That's the copper 2 sulfate. What makes it a salt? Ionically bonded between the copper and the sulfate. Okay? And it has waters attached to it. Now, have you ever bought a pretzel or a salt bagel or something, and then the next day you look at the salt on your pretzel or your bagel and it's like watery?
Yeah. Because it absorbs the water.
It absorbs the water. Okay? So the salt becomes hydrated with water molecules attached to it, and it's getting the water from the air around us.
Moisture.
Now, when it does that, that salt gets heavier because it has now 5 waters attached to it. So let's figure out how much this entire copper 2 sulfate with 5 water molecules attached to it is going to weigh. It is called copper 2 sulfate pent because there's 5 waters. Copper 2 sulfate pentahydrate. 5 waters. Pentahydrate. What?
So it makes sense.
It does make sense. Okay? Like if I had something that had 2 waters on it, would it be pentahydrate? It would be dihydrate. See how smart you guys are? All right, good. So now we've got CuSO4, copper 2 sulfate, dot 5 H2Os. Let's find the entire mass of this whole thing. Because ultimately, what we want to do is we want to find the percent of water in the copper 2 sulfate pentahydrate. How much water is in this thing? So let's figure out how much the copper 2 sulfate weighs. Copper, 1 times 64. I'm going fast. You need to be following me. All right, sulfur. There's one of them. It weighs 32. I'm not telling you where I got these numbers from. You should know this. And if you don't, raise your hand and ask so that we can catch you up to speed. Oxygen, there's 4 of them. They weigh 16 apiece. That's a total of 64. So the copper 2 sulfate weighs 160 grams. If you don't believe me, add those all up.
Can we keep the sulfate together? When we're writing that down.
What do you mean by that?
It's like just keeping like one line, SO4.
Well, you have to figure out how much the S weighs and how much the O weighs. So you still have to add them together, no matter however you write them. Does that make sense? You're thinking about balancing? Yeah. We're just finding gram formula mass. We're just looking how many coppers, how many sulfurs, how many oxygens. We're adding all those suckers together, and we're getting 160 together. Okay? And these numbers are coming from the mass on the periodic table. So what that means is this blue spot right here weighs 160 grams. How much does the water weigh? 18. Water, there's 2 hydrogens, and there's 1 oxygen, which means it weighs 18 grams per mole. That means 18 grams per group. How many groups do I have here? 5. So each one of these is 18. What's 18 times 5? 90. 90 grams of water. Okay. How much does the whole thing weigh? 250 grams. What did you say, Meg? Perfect. I knew you said that. Woo! Go me. Okay? Now, understand what happened here. We found what the mass of the entire thing was. We also found the mass of what just the copper 2 sulfate weighed. And we found out what the mass of the 5 waters weighed. And these two added together, 160 and the 90 added together gave us, I'll put it in green, 250, which is the whole thing. Now, what happens if I want to find the percent of water? Let's write the let's write the formula down so we make sure we put our numbers in our calculator correctly. The part that is water, P, over the whole thing times 100. What part was water? 90. What did the whole thing weigh? 250 times 100. And you should get 36.1 or 36% water. Check my math. You got 36 is close enough. Okay? 36% of this mess that I've got up here is water. Okay? How much time do I have?
2 minutes.
Okay. I'm going to stop the video here. Tomorrow we will continue this. Hold on. Don't go anywhere. I'm not done. Stop video.